All right, let's jump right in. We always hear about AI as this super brilliant, almost magical thing, right? But have you ever stopped to wonder how we actually build a mind for one? I mean, how do you give it a memory? Well, that's exactly what we're going to unpack today. So here's the thing, and it's this kind of funny paradox you run into when you work with AI agents. You can ask it to explain, I don't know, quantum mechanics, and boom, it'll spit out a brilliant answer. But then you ask it to remember something you just said 5 minutes ago, and you get nothing, a total blank slate. So what gives? Well, it all comes down to one very specific, very fundamental limitation. And yeah, engineers actually have a nickname for this. They call it the goldfish brain problem. And look, it's not forgetful like a person is. It's more fundamental. It has a built-in limited attention span, a bottleneck, really. And that bottleneck shapes everything about how it thinks and remembers. That bottleneck, it has a technical name. It's called the context window. The easiest way to think about it is like this. It's the AI's short-term memory. It is everything, and I mean everything it can hold in its mind at one single moment. And if a piece of information falls out of that window, poof. As far as the AI is concerned, it never existed. So that's the big question, right? How in the world do you build a long-term memory for something that fundamentally has no long-term memory? Well, you get really, really clever. Engineers have come up with a whole bag of tricks, these awesome hacks and strategies to get around this context window limitation. So let's pop the hood and see how they do it. Okay, so the first big idea is something called context paging. And honestly, the best way to get it is with a simple computer analogy. So the AI's context window, that's like your computer's RAM. It's blazing fast, but it's also pretty small. It's what the AI is actively thinking about, like right this second. And everything else, every other fact, every single past conversation, that all gets stored in a huge external database. Think of that as your computer's hard drive, or even better, a massive library. It holds a ton of information, but it's way slower to go and find something. And this is the really cool part. The AI basically learns to manage its own memory. So when it needs a fact that isn't right there in its immediate brain, the context window, it actively goes and searches its library, that big archival memory we talked about. And then, this is the key, it pulls or pages that specific fact into its context window, just for the moment it needs it. It's not passive. It's a totally active, deliberate process of remembering. Okay, cool. But what happens when a conversation just keeps going and gets super long? Well, that brings us to trick number two, context compression. Instead of just letting that precious context window overflow with chatter, the system is smart. It'll hit pause every once in a while and tell the AI, hey, summarize this conversation so far. So the AI boils everything down to just the key facts, throws out all the how are yous and the conversational fluff, and then puts that nice tight summary back into its memory. Super efficient. All right, another big headache is just overwhelming the AI with too many options. Imagine you show it like 100 different tools it can use. Just the definitions of those tools would clog up the entire context window. It would get totally confused. So to get around this, engineers use a clever technique called progressive disclosure. Here's how it works. First, the AI only sees big, broad categories, like file tools or web tools. And only after it decides, okay, I need to mess with a file, then the system loads the definitions for the specific file tools into its memory. Yeah, it's kind of like opening one drawer in your toolbox at a time instead of just dumping the whole thing out on the floor. Much cleaner. Okay, now we're at my absolute favorite trick. This one is so smart. So let's say you want an AI to analyze a big spreadsheet, right? Say 10,000 rows of data. The dumb, brute force way to do it would be to just copy and paste all 10,000 rows right into its context window. I mean, that is just wildly inefficient. It's super expensive in terms of computing power, and honestly, it's pretty much guaranteed to fail. But there's a much, much smarter way. It's a technique called code as context. Get this. Instead of showing the AI all the data, you just ask it to write a tiny piece of code to analyze the data for you. The AI never even has to see the raw numbers. It just interacts with the file using its own little script. And the results? The only thing that ever has to enter the AI's super valuable, very limited short-term memory is the final answer. All that mess, all 10,000 of those rows, they get processed completely outside the AI's brain. And its context window, it just sees the tiny, beautiful, simple result. It is such an elegant way to save memory. But And there's always a but, right? Here's the catch. When you build these really complex, clever memory systems, you also create really complex and clever ways for them to fail. And we're not talking about simple bugs here. No, these are more like AI cognitive biases, these weird, strange glitches that pop up precisely because of how its memory is designed. They're basically the ghosts in the machine. Okay, first on our list of glitches, context pollution. This happens when that paging system we talked about pulls in some information from the library that's, on the right topic, but it's not actually relevant to the specific question you're asking. These little distractor facts can just completely derail the AI's train of thought and send it spiraling towards a totally wrong answer. The source material for this has a perfect name for this. It calls it a Chekhov's gun bias, and that's exactly what it is. In storytelling, Chekhov's gun is that old rule. If you put a gun on the wall in Act 1, it has to be fired by Act 3. Well, AIs have a pretty similar bias. They basically assume that any piece of information you put inside their context window must be important for some reason. So they'll try their best to use it, even if it's total junk.
All right, next up, we've got a really subtle one called context drift. So when a task starts, the AI's main goal, its system prompt, like, "You are a helpful assistant," is right there at the top. Front and center, clear as day, can't miss it, simple.
But then, as the task goes on, maybe after 50 steps and a bunch of tool calls and a few error messages, that original core instruction gets pushed up, further and further away in the context window. It gets buried under this mountain of just mental clutter, all the little steps it took along the way. And what happens is the agent literally loses sight of its main goal. It kind of forgets what it was even supposed to be doing in the first place. Now, if you think that's weird, things can get even stranger when you have multiple AIs working together. This is a phenomenon called the hallucination cascade. And here's how it starts. All it takes is for one single AI agent to just make something up, to invent one little incorrect fact. The next agent in the chain, it just accepts that made-up fact as pure gospel truth. No questions asked. And then a third agent comes along and builds on top of that error, and the mistake just gets bigger and bigger, amplified down the line until the entire system is running on a complete and total fantasy. And finally, we have something called tool call thrashing. Oh man, this one is maybe the most frustrating to watch happen in real time. This is when an agent gets stuck in a loop, just trying the exact same failing action over and over and over again. It's exactly like watching someone just clicking and clicking and clicking a button on a website that's frozen. You know it's not going to work, but they just keep doing it. The agent just doesn't have that self-awareness to stop, take a step back, and think, maybe I should try something different. So, when you put all this together, what's the big picture here? What does it all mean? Well, all these incredible tricks and these totally bizarre failures, they tell us something really profound. We aren't just building better computer programs anymore. We're learning how to work with and how to debug a completely new kind of intelligence, a new kind of thinker. So let's boil it all down. Here are the key things you should really take away from all this. First, that AI memory isn't like ours. It's a complex illusion built on a foundation of really clever engineering tricks. Second, those very same tricks create their own unique, kind of weird cognitive biases, like that Chekhov's gun problem, which brings us to number 3. If we want to build AI agents that are actually robust and reliable, we have to understand these glitches. And finally, remember that this is all part of a much bigger journey. We're learning how to work with a mind that is, in many ways, truly alien to our own. And that leaves us with one last kind of provocative thought to chew on. As we build these AIs with better and better and more sophisticated memories, we've got to ask ourselves, are we just building AIs that are better at remembering stuff? Or are we also accidentally building AIs that have more complex, more creative, and maybe even more convincing ways to be completely and utterly wrong? Definitely something to think about.